Good morning to all. Today we are going to see about nitrogen containing organic compound. Nitrogen containing organic compound. So different compounds are there. For example, uh, amines NH2. So amine, that is alkyl amine, primary amine. Then amide, alkyl amide CONH2. Then alkyl cyanide RCN, then isocyanide RNC. These are different compounds are there. Okay. Then especially the aromatic compound, aromatic amine compounds are there. Okay. Then aromatic cyanide compounds are there. So now we are going to explain all the compounds, are not all the compounds, but we are going to explain about only amines. Only amines. Okay. So we knew that amines are classified into three types. Okay. Before that, amines are the derivatives of ammonia. They are ammonia derivatives. Ammonia derivatives. Okay. So it is prepared from ammonia. Ammonia formula NH3. If we replace one hydrogen from ammonia and introduce one alkyl group, that is R minus 1, that is one hydrogen replaced from ammonia, we get RNH2. Okay, RNH2. Maybe we replace another one hydrogen, that is two hydrogen from ammonia molecule, we get RNH. Then, suppose we replace all the three hydrogen from ammonia molecule, the product is RNN. Okay, so we get three different types of amine. Now we are going to classify. So we replace one hydrogen from ammonia, we get NH2, that is called as primary amine. Primary amine. Primary amine. Okay, 1/0 means usually we can say primary. Okay, primary. Then NH2 we replace, replace two hydrogen from ammonia molecule, that is called as secondary amine. Secondary amine. Then likewise all the three hydrogens so replaced from ammonia, it is called as tertiary amine. Tertiary amine. Tertiary amine. Okay. So one more type also possible, that is quaternary ammonium salt. If nitrogen replace a lone pair of electron, that is nitrogen contain a lone pair of electron. What is lone pair of electron? The electron does not involved in bond formation. Okay, does not involved in any type of bond formation. So if it lose the lone pair of electron, it is called as R4N plus quaternary. Okay, quaternary ammonium salt. These are the basic classification about amine groups. Okay, the aliphatic amines, not aromatic. Usually amines are classified into two types, aliphatic and aromatic amines. So it's aliphatic amines. Okay, aliphatic amines. Okay. So further we classify two types, simple and mixed. Simple and mixed. So simple amine and mixed amine. Mixed amine. Okay. So this usually we can classify or explain the secondary amine. Okay. The two alkyl groups connected with the nitrogen is same. That is symmetric. Symmetry alkyl groups are connected with, or symmetric groups are connected with the nitrogen. That is called as simple amine. Maybe it is different. We can say it is a mixed amine. It's like a ethers. Okay. Yeah. When we study ethers, we are classified simple ether, mixed ether. The same alkyl group connected with the oxygen is called simple ether. Two different means mixed ethers. Same like here also the same. Okay. Example. Yeah, that is CH3 NHCH3. That is simple ether, simple amines, symmetrical amines. Okay. Then mixed amine, CH3 NHC2H5. Okay, these are the example. Okay, that's a mixed. That is unsymmetrical amines. Unsymmetrical amine. These are the example. Okay. Next, we are going to prepare about amines. We are going to see about the preparation of amine. Three classes of amines: primary, secondary, and tertiary. Okay, we are going to see about the preparation of the three classes of amines: primary amine, secondary amine, and tertiary amines. Okay, primary amine, secondary amine, and tertiary amines. Okay. So, first of all, alkylation. It's a Hoffman method. Hoffman method. Alkylation of ammonia. Okay, that is A. Alkylation of ammonia. Preparation of three classes of amine. Alkylation of ammonia. Before that, we have to know about one thing. That is, amines are pyramidal shape. Pyramidal. Okay, pyramidal shape. It has uh, one lone pair of electron. Actually, the hybridization is sp3 hybridization. Okay, the hybridization of amine is nitrogen is sp3. So the sp3 hybridization geometry should be tetrahedral, but it contains one lone pair of electron. So it is a pyramidal shape. Pyramidal in shape. Okay. Anyway, alkylation of ammonia. Okay. We take one alkyl halide or X, any alkyl halide. Okay, any alkyl halide. For example, CH3Br react with ammonia molecule NH, H and H. NH3 molecule. What will happen? The HBr is eliminated. First step, we get a primary amine CH3NH2 primary amine minus HBr primary amine. Okay, it's a primary amine. Further, we have to add one more molecule of ethyl bromide. We have to add one more molecule of ethyl bromide, that is CH3Br. Again, one of the hydrogen from the amine group and bromine is eliminated. We get secondary amine. Okay, it's a primary amine, it's a secondary amine. Okay, maybe we have to add one more molecule of alkyl halide, that is methyl bromide. Again, hydrogen bromide is eliminated. We get tertiary amine. Okay, tertiary amine. Okay, it's a preparation of three classes of amine. The Hoffman method. First one is alkylation of ammonia. Alkylation of ammonia. Next one is alcolysis of ammonia. Alcolysis. Okay, we take one alcohol and add ammonia. This process is called alcolysis. Alcolysis. We have to see. Alcolysis of ammonia. Take ethanol, C2H5 ethanol or methanol, plus ammonia, NH, H. The water molecule is eliminated. First up we get primary amine, C2H5 NH2. Primary amine. Here the reagent is important. It's Al2O3, aluminium oxide at 350 degrees Celsius. Okay. Then we have to add one more molecule of alcohol, ethyl alcohol. The same process is repeated. Okay, that is as what we learned in what is alkylation method. Okay, for example, see here C2H5. Oh, guys, we get secondary amine C2H5 NH C2H5. Okay, again removed. Further, we get tertiary amine, that is C2H5 N C2H5 C2H5, tertiary amine. This is a tertiary, this is secondary. The same process will repeated. Okay, the same process will repeated. Okay, next one is reduction of nitro compound. Okay, what are nitro compound? The organic compound contain nitro group, NO2 group. Okay, the organic compound contain NO2 group. It is called as nitro compound. So the nitro compound reduced in the presence of some powerful reducing agent, strong reducing agent, that is metal acid, tin, HCl. Okay, usually we can use tin, tin and HCl. So we take one nitro compound or NO2, the reagent is SN-HCl, tin and HCl. Okay, tin and HCl, or we take any other zinc and HCl. The product is RnH2 plus what? Water. water. Okay. What is reduction? Addition of hydrogen. Addition of hydrogen. Here, 4 hydrogens are added. Okay, 4 hydrogens are added. This is the reduction of nitro compound. Preparation of amine. That's a primary amine from the nitro compound. Reduction. Okay, nitro compound. Okay. Then Mendes reaction. Mendes reaction. Okay, Mendes reaction. Yeah, Mendes reaction. Reduction of nitrile. Mendes reaction. Next one is Mendes reaction. Mendes reaction. That is reduction of nitriles. Reduction of nitriles. Reduction of nitrile. What is nitrile? Organic chemistry. In chemistry, we can say CN is the nitrile compound. Okay, so it nitrile. Okay, reduction of nitrile compound. We take ethane nitrile, CH3, C, triple bond N. Ethane nitrile. The reducing agent is we got the same reducing agent we can use. We get ethane amine, CH3, CH2, NH2. Here also we have to add 4 hydrogen. So this reaction is called Mendes reaction. Okay, Mendes reaction. Mendes reaction. Mendes reaction. Okay. Yeah. Some other method also there from the amide. Hoffman bromide synthesis. Important question. Hoffman bromide synthesis. Hoffman bromide reaction. Okay. Here in this reaction, the CH3CO NH2, that is amide group. Amide group is converted into amine group. Okay, that is CH3NH2. CH3NH2. Okay, primary amine. This is called Hoffman bromide synthesis or degradation. Hoffman bromide synthesis or degradation. Synthesis. Okay. So amide group converted into what? Amine. Converted into amine. Okay. Primary amine. Here the product should be contain 1 carbon less from the reactant. That is amide. Here we see 2 carbon is there, but product contain only 1 carbon. Only 1 carbon. Okay. So carbon bromide reaction. Next one is important, preparation of primary amine. Only for primary amine. Habriel phthalimide reaction. Habriel phthalimide reaction or phthalimide synthesis. So only for the preparation of primary amine. Habriel phthalimide synthesis is preparation for primary amine. Here the phthalimide is the substrate, starting material. Okay, phthalimide. Okay, it is obtained from phthalic acid. We know phthalic acid. It's an aromatic dicarboxylic acid. Phthalic acid is the aromatic dicarboxylic acid. It is called as phthalic acid. Okay, COOH. So the aromatic dicarboxylic acid is called as phthalic acid. So phthalic acid react with ammonia NH3. Yeah, with the elimination of 2 molecules of water, we get phthalimide. Okay, this phthalimide is the reactive part of our synthesis. That is Habriel phthalimide synthesis. CONH. Habriel phthalimide. Okay, we can see the reaction now. It's only for the preparation of primary amine. So phthalimide. CONH. Okay, phthalimide. What is the name of this compound? Phthalimide. 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 Okay. First, phthalimide is reacted with KOH. Here, a molecule of water is eliminated. Okay, molecule of water is eliminated. What is the product? Minus H2O is eliminated. This hydrogen and OH water. The potassium added to nitrogen. That is, we get potassium phthalimide. Okay, CONK. What is that? Potassium phthalimide. Further, we have to add one alkyl halide. That is RX. Generally, we can say REX Otherwise, we take specifically ethyl halide, C2H5Br, ethyl bromide. What will happen? This potassium and bromine combine to give KBr and replaced. We get the product alkyl phthalimide, N-alkyl phthalimide. Okay, the correct name is N-alkyl phthalimide, CO, N-alkyl phthalimide. Okay, yeah, that is NC2H5 followed by hydrolysis, HCl. Okay, hydrolysis, we get our amine, that is HCl. Hydrolysis taking place. Okay, hydrolysis, we get phthalic acid along with primary amine. Phthalic acid along with primary amine. Okay, or NH2. This reaction may be take place in the presence of basic hydrolysis. We get phthalate salt. Okay, phthalate salt. So this is the method of preparation of primary amine by Habriel phthalimide synthesis. Habriel phthalimide synthesis, C2H5NH2. For the same alkyl group, here we are used ethyl group. So C2H5NH2, Habriel phthalimide synthesis. Important question. Only for primary amine. Next, here the hydrolysis is too difficult. It's not an easy process. So we have to use hydrazine. Okay, here we have to use hydrazine, NH2, another one base, hydrazine, NH2. We get our expected product. Okay, we get the actual product, the primary amine. What is the product? C2H5NH2. C2H5NH2, and also we get the intermediate, that is not intermediate, another one product, CONH. Okay, another one, CONH. This is called as Habriel phthalimide synthesis. Okay, Habriel phthalimide synthesis. Okay, you understand? Yeah. Next one is from Cricknode reagent. How to prepare amines from Cricknode reagent. What is Cricknode reagent? Cricknode reagent is the alkyl magnesium or alkyl or aryl or MgX, the Cricknode reagent. X is the halogen. Usually we can use bromine and chlorine also we can use. Okay, bromine and chlorine, X. Or is the alkyl group or aryl group, alkyl or phenyl group, aryl group. Okay, so here the Cricknode reagent is added to chloroamine, that is RMgX is added to general formula. I wrote here RMgX react with chloroamine ClNH2. We get RNH2 is a product, primary amine plus XMgCl. Okay, XMgCl is a product from Cricknode reagent. Okay, simple. Or maybe alkyl or aryl group. Usually we have to prepare alkyl. Okay. Next one is Schmidt reaction. Okay. Here the carboxylic acid, the Schmidt reaction, preparation of amines by Schmidt reaction. Here the carboxylic acid react with hydroxo acid, that is hydroxoic acid. For example, RCOOH, R means alkyl group. Okay, we have to any alkyl group. COH in the presence of N3H, hydroxoic acid, N3H or N3H. Okay, in the presence of concentrated sulfuric acid. What's the product? We get amine or NH2 plus N2 plus CO2. This reaction is called as Schmidt reaction. Okay, Schmidt reaction. Okay, understand? These are that's all about important preparation of amines. Another one is Manich reaction. Preparation of amine by Manich reaction. Here the N substitute amines are we can prepare. Okay, Manich. This one is Manich reaction. Manich reaction. Manich reaction here. the RCO NH or dash, that is N substituted amines. N substitute, okay, alkali substituted N. So N substituted amines react normal only. Okay, there is four reduction. Same reaction, man. It's also the reduction. Okay, reduction. The presence of lithium aluminum hydride we get or CH2NHR. Okay. See here, this CO is amide linkage is reduced. So the product is what's the product? N substituted amine. N substituted amines. Okay. Understand? N substituted amines. Okay. Yeah, that is secondary amine. Secondary amine. That is a managed reaction. That's all about the important preparation about amines. Important preparation about amines. Now we are going to about how to distinguish three type of amines. Different substances are there. For example, nitrous acid, HNO2. We have to separate. This is distinguish or separate three type of amines, and also benzene sulfonyl chloride. Benzene sulfonyl chloride also we can use to separate three class of amines. Okay. Then another important that is distillation process. The primary and secondary. First I said the benzene sulfonyl chloride. That's another one is nitrous acid. The benzene sulfonyl chloride is called as Hinsberg reagent. That is classify or distinguish three type of amines. Here separation. We have to use fractional distillation method. Fractional, three type of amines separated by fractional distillation method. What is fractional distillation method? The three substances have different boiling point. One is less boiling point substance, first volatile, we collect the vapor and condense, we get back the same substance. Okay. Here the primary amine, the boiling point is 17 degree Celsius. Then secondary amine, the boiling point is 56 degrees Celsius. Then the tertiary amines, the boiling point is 96 degrees Celsius. So the mixture taken in the fractionating column, fractionating tube, we have to apply heat energy, it is vaporized at different temperature, we collect the vapor and the condense, we get back the three class of amines. Okay. Another one is with the Hinsberg reagent. With the Hinsberg reagent, okay. Hinsberg is important. Hinsberg reagent or Hinsberg method or Hinsberg. Yeah, we can say both are correct only. Hinsberg method. Here we have to use Hinsberg reagent. The reagent is important. Reagent. That is phenyl, CH5, SO2Cl, benzene sulfonyl chloride. It's a Hinsberg reagent. Very simple. In a competitive examination point of view, we have to easily memorize the primary amine. Primary amine react with Hinsberg reagent, SO2Cl. Hinsberg reagent, it gives the salt soluble in base. Okay, give the salt soluble in base like NaOH or alkali, not a base, alkali. Sorry, not a base, alkali. What are alkali? The water soluble base are called as alkali. So this NaOH is the alkali. So when primary amine react with the Hinsberg reagent, it gives the salt. The particular salt is dissolved in or soluble in base. That is alkali. Yeah, alkali base. Okay. Then secondary amine. Secondary amine also the same reagent. CH5, SO2Cl. It gives the salt but insoluble in alkali. Insoluble in alkali. From this point we have to conclude which is the primary amine, which is the secondary amine. The tertiary amine does not react with Hinsberg reagent because the amine does not contain hydrogen. Okay. Here the elimination of hydrochloric acid HCl, the hydrogen is important. So this is the classification of that is three type of amines: primary, secondary, tertiary amines. Okay. Yeah. Then next, nitrous acid. Okay, with nitrous acid. Do you know nitrous acid? The formula HNO2. It's not so important. Nitrous acid here, one of the important reactions is there. The characteristic of secondary amine, that is Lieberman test. Lieberman's test. Okay, Lieberman's test. Okay, nitrous acid. Here, primary amine react with nitrous acid. First of all, you want nitrite intermediate followed by it with the alcohol. So, primary amine react with nitrous acid, that is HNO2. It gives alcohol. Okay, alcohol. Maybe ethylamine give ethyl alcohol. Then secondary amine with nitrous acid HNO2, it gives yellow color oil. Syrupy liquid, I think. Syrupy liquid. Yellow color oil, not a liquid, oil. Yellow color oil. It is the N-nitrosoamine. N-nitrosoamine. Okay, N-nitrosoamine. Okay, N-nitrosoamine or nitrosoamine, yellow color oil. It's insoluble. Then tertiary amine give the salt. Okay, nitrite salt. Tertiary amine plus HNO2, it gives nitrite salt. These are about the important preparation of amines. Okay, important classification of amines. Okay, not a preparation, classification. Next one is, another one is, there is the physical properties of, when we see the physical properties of amines, a fishy odor. Okay, fishy odor, smell, okay, bad smell, substance, the amines. Okay, the lower numbers are liquid, higher numbers are solid. These are the important one. Then the boiling point, basic character. So secondary amine is more than that's all. We'll see the physical properties, because aliphatic amines are more basic than aromatic amine, because aromatic amine, the lone pair of electron not available for the donation, it involved in the resonance. These are the important points we can see later. Okay, it will take some time, we'll take later. So before that, we have discussed one or two important question asked the previous year, this year, and also previous years. One or two questions. Okay, one or two questions. See, here 2 is 25 need questions. Amine. Okay, first. In this lesson, there are two questions from Amine. First one is the correct of decreasing, the correct order of decreasing basic strength of given amines. I told you, no, the benzene amine, that is structure this one. So benzene amine or aniline. This lone pair of electron not available for the donation because involved in the resonance, like structure, resonance structure. So less basic compared to aliphatic amine. So the option is first one is correct. Okay. So ethyl ethane amine. What is structure? N-ethyl ethane amine. N C2H5. Okay. N-ethyl ethane amine is greater than ethane amine C2H5 NH2. Then N-methyl amine, because usually secondary amines are less basic, but ethylamine is an exceptional case. Okay, so methylamine and benzene. Benzene is the least because the electron is not available for the donation. Okay, the quick revision. We have to see the quick point how to remember this section. See here, the basicity of amine is primarily determined by the availability of lone pair of electrons in the nitrogen atom. Okay, what are bases? Only they have to accept a proton H plus, or they have donate a electron. They are called as bases. See here, the basicity of amines primarily determine the availability of lone pair of electrons on the nitrogen atom. Electron donating group, likely alkyl group. In the presence of plus I group, increase the basicity. Okay. Electron donating group increase the basicity of increase electron density, while electron withdrawing group like aryl group due to resonance decrease basicity. For aliphatic amine, in aqueous solution, all this typically secondary, primary, tertiary ammonia due to the combination of inductive and solvation effect. But in the gaseous phase, only inductive effect is applied. Okay, in aqueous state, we have to account the solvation effect also. We can see later what is solvation effect. Okay. The aromatic amines are generally much weaker base than aliphatic amines due to resonance. That is like told. Okay, so the aliphatic amines are more basic. So answer of that question. Okay. Then another one goes. Two questions asked this year. Another one is predict the major product P in the following sequence of reaction. Predict the major product P in the following sequence of reaction. Okay. What is the answer? How can we find? Very easy question. Okay. So the given compound is the alkene. Alkene. What's the first one? HBr benzyl peroxide. HBr benzyl peroxide. Here, addition of HBr is taking place. Okay, addition of HBr is taking place. In the presence of peroxide, we have to add HBr to the unsymmetrical alkene. We have to follow the Markovnikov rule. Markovnikov rule. What is Markovnikov rule? The HBr, HX, or the addition of double bond unsymmetrical ketone, unsymmetrical alkene. If addition of HBr added to the unsymmetrical alkane, the hydrogen is preferentially added to the double bonded carbon which one contain more number of hydrogen atom. This is called Markovnikov rule. Then what is anti-Markovnikov rule? HBr in the presence of peroxide, the reaction follows anti-Markovnikov rule. What is anti-Markovnikov rule? The hydrogen is preferentially added to the double bond which one contain least number of hydrogen atom. So this reaction follows anti-Markovnikov rule. I will draw the structure here. What is the structure? First one. Double bond CH3. So see these two carbon, when we add first step HBr and benzyl peroxide. Benzyl peroxide. Okay, peroxide. What is the product? Anti-Markovnikov rule we have to follow. Anti-Markovnikov addition is possible. So bromine is added this carbon because here two hydrogen. Here one hydrogen, here no hydrogen. Here one hydrogen, here no hydrogen. Okay. So the product should be first product. Yes. Here CH3, here what? Br, first product. Then second one. What we have to add? KCN. When we add KCN, the KBr is eliminated, CN is added. Okay. We get methyl group CN. Okay. What is the last step? Sodium amalgam ethanol. There is a reduction. It reduced to give this product. Okay, this one is the product. 33 is the answer. Okay, when we use sodium amalgam, ethanol, reduction is taking place. What will happen? Here C triple bond N. This group is reduced to give primary amine. Okay, the presence of sodium amalgam and ethanol, the nitrile group. Okay, a cyano group reduced to give primary amine. So C, we have got 4 hydrogen. CH2 and NH2. CH2 and NH2. So these two questions asked this year. Okay, see here. First of all, HBr, we have to follow anti-Markovnikov rule. Hydrogen is added to this carbon. Hydrogen is added to this carbon. Here bromine. Okay. I'll write one more time. See here. Here hydrogen. Here bromine. What is the product? First we get. This is the product. CH3Br. What is the next step? We are at NaCN. KCN. Okay. We get the product. CH3Cn. What is for the reduction? Cyano group reduced to give CH2, NH2. That's all. Okay. This is the explanation of this question. Very simple. Okay. This one and the previous question, this year they asked. Understand? Then quick tips. How can we remember this equation? Very easy. See here. Remember that the regioselectivity HBr addition, that is anti-Markovnikov rule. Select HBr addition the alkene in the presence of peroxide, anti-Markovnikov rule. We get the anti-Markovnikov product followed by CN, good nucleophile, SN2 reaction with alkyl group halides. Sodium amalgam in ethanol is a reducing agent that can reduce nitriles to primary amines. Alkyl nitriles to primary amines. These are about this year question, 2025 question. Very easy question. Okay. Then one more question we have to see. This question. Okay. What is the product? The final product C obtain the following reaction. What will happen? Directly, the bromination is not possible. Halogen is not possible because it's a highly ortho-para directive nature. Okay, so we have to take only one product, ortho or para. We know that the aniline react with bromine water. It gives 2,4,6 tribromo aniline. That's a test for another aniline, white precipitate. Okay, see here. First of all, we have to protect this group. This one also what? Brominated. We have to protect. So we have to add acetic anhydride. Acetic anhydride. What is the product? NHCOCH3. Right here. What's the A? I will write here A. NHCOC acetaldehyde. We have to protect that group, amine group. Okay, followed by bromine. So ortho para directive, but para position is already occupied a methyl group, so ortho is possible. NHCOCH3 CH3Br. Okay, Br. Understand? Now hydrolysis. We get the product. We get the product. What is the product? What's the possible product? When we hydrolyze, the acetyl group is replaces acetic acid. Okay, we get this product. For what purpose we have to add acetic acid, acetic and acetyl and acetic anhydride first? We have to protect the amine group. Okay, it's a product. Okay, understand? Yeah. That's all about some question I was explaining. You know, that's all. So it's the answer. D. D is the answer. Okay, D is the answer. Anyway, thank you. I hope you all understood. Thank you.